Yo, all right, here we go. Final video of integration techniques. Let's take a look at this guy right here. This is one of those problems where you learn all the different techniques and you tend to overthink this one, right? Try to do a U sub, try to do all these different things, but the simplest thing to do here is simply to divide or to break up this numerator over subtraction here. So what the heck does that mean? I can rewrite this as the integral of x squared over radical x minus 5 over radical x. And all I'm doing there is dividing, right? Think about it. If you were to subtract these fractions, you have a common denominator, right? And then you'd be able to do x squared minus 5 over that common denominator. So we kind of like backward subtract the fractions. Sometimes we refer to this as breaking up a numerator over subtraction, which you can do when you have that monomial in the bottom there. So now you might be saying, well, what do I do with this? Well, you're going to want to rewrite this, right? So you're going to want to rewrite radical x as x to the half, right? So I'm going to write radical x as x to the 1/2 here. And the same thing over here. I'm going to write this as x to the 1/2. I'm kind of taking my time with this. So now what does that allow you to do? Well, now you're dividing two terms with the same base, so you can subtract the exponents. So you can write this as, let's see, I'd rather think of 2 as 4 over 2, right? So 4 over 2 minus 1 over 2, that's 3 over 2. So that's going to be simplified to x to the 3/2, right? We learned that in 7th grade. Divide two terms with the same base, subtract the exponents. This guy over here, you're going to leverage what you know about negative exponents. Rewrite this as 5x to the negative 1/2. And now look at this expression. So much nicer looking than this. Integral of a difference of the integrals, and you can do the power rule on both of these guys, right? So here we go. So I want to integrate x to the 3/2. So in my brain, I'm thinking I want to add 1, so I add 2 over 2 to that, right? So I'm going to get x to the 5 over 2, and then when I multiply by 1 over 5 over 2, that's like multiplying by 2/5. So this is a function whose derivative is just going to be x to the 3/2. Now I have minus 5. All right, now I want to integrate this guy. Same deal, add the power, do the power rule. So think of it as adding 2 over 2 to that guy. And so negative 1 over 2 plus 2 over 2, that's x to the 1 over 2. And when I multiply by 1 over 2, that's like multiplying by 2. I get plus c. That's basically it. So 2/5 x to the 5/2 minus 10 x to the 1/2 plus c. All right, and that is a family of functions differing by a constant such that if I took the derivative of this and simplified it, I would get that. All right, so however you want to call this technique, breaking up the numerator over subtraction or addition, or basically just dividing, whatever works, you do it. All right. I've actually seen some people, and I might as well show this because it depends on how your brain works, right? Some people would rewrite this as the integral of x to the negative 1/2 times x squared minus 5. And then they go ahead and distribute that x to the negative 1/2, and it takes them exactly to here. All right, so you can think of it that way too. All right, let's take a look at 14. So 14, again, don't overthink it. It looks like a regular old u substitution is going to work here. So if I let u equal 1 minus 9x squared, du would be negative 18x dx. So the x dx is good. I see that. I don't see the negative 18. Not a big deal. Multiply both sides by 1 over negative 18, which is negative an 18th, right? And you get this. And so now think about it. This chunk of stuff right here is negative 1/18 du. And be careful now. What is this? This is not u. This is radical u. Okay? So now when I go to rewrite this, I'm going to have the integral of, I'll pull out the negative 1 over 18. That's no big deal. And then it's going to be du over radical u, which is not ln. Only ln when it's du over u, okay? So you're like, well, what do I do with that? I'm going to want to rewrite this. So it's going to be negative 1/18 integral u to what power? Hopefully you're saying negative 1/2, okay? For two reasons. Half, that's the radical part. Negative, that's the denominator part. Keep those ideas separate in your head. And so now you can integrate this, right? So you can do the power rule here. So again, I'm going to think of this as, let me add 1 to the power to get my new power. So when I do that, I'm going to get u to the 1 over 2. When I multiply by 1 over 2, that's just 2. So this right here, represents a function whose derivative would be that. All right, don't forget my negative 1/18th, which I won't. And then now I do my plus c. And so I'm going to end up getting here, let's see, negative 2/18, so that's negative a ninth. U, I know what that is, right? U is 1 minus 9x squared. I picked it to the 1/2, and then plus c. And if this is a multiple choice, you would look for that. So it'd be negative 1/9 radical 1 minus 9x squared plus c, right? They could have it this way, they could have it that way. You got to be ready for both. And I think on your problem, this may have been a whole bunch of choices that you had to pick from. So this would be your answer right there. All right. And let's take a look at the last one. All right. So another one that you don't want to overthink. So what the heck do you do with this? E to the radical x over radical x dx, right? Seems like crazy. Well, it turns out a normal u sub's going to work here. And the u that you're going to pick is going to be the exponent. And a lot of times u subs that do work for exponentials, you do let u equal the exponent. So if I let u equal radical x, think about it now, du would be the derivative of that. The derivative of radical x is going to be 1 over 2 radical x. Now I see that, right? This is 1 over radical x dx. So I see this. I don't see this 2 though, but what's the fix? We'll just multiply both sides by 2, right? So then I'd get 2 du equals 1 over radical x dx. So this 1 over radical x dx, this part right here, right, that's like a 1 there, that's going to be your 2 du. And then this right here, this isn't u, this is e to the u. So when you rewrite this, you can pull the 2 out, integral, and it's simply going to be e to the u du. Right? If you were to back substitute u and du into there, you'd get that same exact integral. And so this is easy now, right? A function whose derivative is e to u, easiest one in America. It's just e to the u, and then plus c. And then you picked u, so you can back substitute. U is equal to radical x, right? And that's it, and that's your answer. And again, if you want to, since we have some time here, let's check it. So I found a family of functions differing by a constant such that if I took the derivative of this, I should get my original integrand. So let me check that. Let me take the derivative with respect to x of 2e to the radical x plus c. Well, derivative of sum of the derivatives. Derivative of c, that's just 0 because the derivative of constant 0. The derivative of a constant times a function is going to be the constant times the derivative of the function. The derivative of e to stuff is e to stuff times the derivative of stuff, right? And what happens here, these 2's are going to cancel, and then you just end up getting e to the radical x over radical x, which is exactly what the integrand was, right? So you know that you did it right. So that's kind of a general rule of thumb that when you're doing a u substitution for exponentials, usually letting u equal the exponent usually works, all right? This isn't the only way to do this, by the way. What's bananas, and I'll leave this up to you if you want, is you could have let u equal the whole thing. So in other words, well, almost the whole thing. You could have let u equal e to the radical x, all right? And this will also work. It's going to look slightly different in this form, but when you get to your final answer, it's going to look exactly the same. So you should try that, quite honestly. Let u equal radical x, figure out your du, figure out how to rewrite it, and see if you can get the same exact answer. You should be able to, okay? All right, that's it. Final video, done. Go get those AP classroom assignments.